Welcome everybody to this new MICROPTICS masterclass presentation. Today I will talk about MetaClass system and I explain why and how to use this karyotyping and FISH for infertile couples. You will find a button on the top of your screen that you can write your questions, and at the end of this presentation I will answer all. So let's start. So MICROPTICS is a company specialized in male infertility market since 1989. Our main product are the CASA systems. We have two versions of the CASA system, the CA Evolution, that it's a standard microscope with a computer, and the new SCA scope that it's all-in-one CASA system. The CASA system, for people that doesn't know, it's a computer-aided semen analysis. So it's a system that automatically analyzes the different semen parameters following the WHO criteria. But we also have the MetaClass. That is a system for automatic karyotyping and FISH. So the karyotype describes the chromosome composition of a patient, allowing the identification of genetic problems related to infertility or specific syndromes of diseases. So here we have a typical karyotype for different chromosomes. You can see the different chromosomes. And how to read the karyotype. So in a karyotype, there is normally 46 chromosomes, and the X for XX for if it's a female, and XY if it's a male. But in some cases, there are some numbers that there are just one chromosome or three chromosomes, that it's trisomy. And this is what is interested for us because there is an aneuploidy that can be a sign of infertility. So why is necessary to perform this analysis in an infertile couple? To find out why they can get pregnant or suffer from multiple embryo miscarriage. Okay, so if you have a couple that has a miscarriage, it's good to check the karyotype. Also to detect a variety of genetic disorders in parents that could cause infertility. So there are some genetic disorders like Robertsian translocation, the Klinefelter syndrome, that can cause infertility. And also to minimize the risk of passing a genetic defect to the embryo after doing an ICSI or a test. So if there is a problem in the sample, at the moment that you do the semen sample, it's good to do the karyotype. And when to do it? Normally, if you have a semen sample with azoospermia, so there are no sperms, or a severe oligospermia, that there are less than 5 millions per milliliter, it's good to do a karyotype. Also, if the couple has 2 or more consecutive embryo miscarriage, also if there are implantation failure, stillborn birth, if the female partner has been diagnosed with primary ovarian dysfunction, or prior always to an ICSI or a test. So do the karyotype in these cases. Types of different abnormalities that you can find. There are 2 types, numerical chromosomes abnormalities. Okay, that some chromosomes are more like trisomy or less than only one. And this is one of the possible effects of this male infertility. And another abnormality can be the structural chromosomes abnormalities, that is the balanced translocations. This can be cause of oligospermia and recurrent miscarriage are common. And also inversions or deletions of chromosomes pairs. And the FISH analysis, it's a molecular cytogenetic technique that uses fluorescence. In that case, in the karyotype, we use a bright field microscope. In the FISH, it's necessary to use fluorescence to detect and localize the presence of absence of a specific DNA sequence on chromosomes. This is an accurate method for detecting small genetic variations, such as deletions or duplications in chromosomes, or the presence of genes associated to specific pathologies and syndromes. For example, in this image, the red dots are the X chromosome, and the green is the Y. So here we can see if there is a problem in these two chromosomes. And why and when is necessary to do the FISH? There is a technique that is the sperm and haploid test. That is, in this test, normally we analyze 5 types of chromosomes: the 13, the 18, the 21, the X and Y. And what we do is check if in these chromosomes there is a problem, that there is more or less chromosomes than 2. Also can be extended to cover other chromosomes if this I will base it on the patient medical background, like chromosome 16 and 22. These two chromosomes, normally it's a case when there is a repeat pregnancy loss. So in pregnancy loss, it's better to check these two chromosomes. And finally, the pre-implantation genetic diagnosis, the PGD, in blastomers for couples with structural and numerical chromosomes abnormality. So if the couple, one of the two, has problems in the chromosomes, then it's good to check the blastomers to see if there are problems there. So the MetaClass system is composed with a computer with Windows 10, can be a desktop or a laptop, a standard microscope with an objective of 100 oil, and a digital camera, a Basler camera, that is connected to the microscope and gives the images to the computer. The good thing of the MetaClass is that it's the same hardware as the SCA. So the people that has already the SCA can use all the hardware and they just need to buy the software. And also, if you want the FISH option, then it's necessary to have the fluorescence. So you have to buy the fluorescence with the different filters and attach to the microscope. And the MetaClass system has 3 independent modules. So the first module is the karyotyping that can analyze bands G, R, or Q, and from the metaphase will generate the karyotype. The MetaClass FISH that analyze different images of fish in fluorescence. And finally, the MetaClass database that from the database you can print reports, you can see all the different analyses, you start the analysis, and you have a database with all the analysis from all the patients. Okay, so I will show you with a demo how it works, the MetaClass system. So I run the MetaClass software. In the first screen, it asks me the user and the password. So the system will identify what each technician will do in all the session. So the first screen is for identify the sample. So I write here the patient history number. And here in this area, I can identify all the settings of the sample. All these labels can be customized and set as the value that the user wants. And here I can select what I want for each sample, and everything will be saved in the database. So once I have the identification of the patient, I go here to analyze, and I will start the analysis. So I put the sample in the microscope. I will use the 100 times objective oil, and here it's possible to select which band I analyze, if I will analyze G, R, or Q. Okay. So when I press the camera, the system asks me first if I want to do a karyotype or a FISH. In that case, I will do a karyotype. I press OK, and this is the image that I get from the microscope. So once I have the image, the first thing I do is analyze, and the system automatically identifies each chromosome and classifies in the karyotype. So from the karyotype, there are some chromosomes that are not well classified, and I can change some settings. For example, here, there are 2 chromosomes that are not well separated because they are touching. So I can do a automatic separation. When I select here automatic, the system tells me if this is the correct separation. If it's not correct, I can retry, and in that moment the separation is correct, so I press OK, and the system automatically classifies each chromosome in the number that is correct. Also, it's possible, for example, I can do a manual separation. So I press here, separation, manual, and in that case, I use like a scissors, I do that like that, and the system automatically separates. Also, it's possible to do automatic crosses. So for example, here, in that case, I can do cross, automatic, and the system separates each chromosome. Also, it's possible to do manual cross. In that case, I put 4 points where are the cross, and the system separates. Okay, and this for all the chromosomes that are not correctly classified. Once I have all the chromosomes ready, also it's possible to check if everything is well analyzed, or for example, maybe there are a chromosome that is not in the image, so I always can add more images. So I go again in capture, and here at the bottom, I can see other chromosomes that are maybe not in the first image. So what I can do is just select like that, and the system adds the chromosomes in the first image. If it's, for example, not good, I can also remove the chromosome. So once I have all the chromosomes ready here, the system, it's possible to move some chromosomes if they are not correctly classified. So I can do like that, just change the position and classify with the correct thing. For example, in that case, this chromosome also is not good because there are 2 chromosomes. So I can come back here and make a separation, automatic separation. And now, if I come back here, I see here all the chromosomes classified. Also, for each chromosome, it's possible to do some changes. For example, if I want to change the contrast of this chromosome, I can go here and I can manually change the contrast, and I can give more contrast. Also, it's possible to see the original image of all the chromosomes. This is the original image, or enhance the image contrast. Okay, so it's always possible to change the settings of each chromosome. Also, for each chromosome, it's possible to change the position. For example, if I press the right mouse button, I can change the position. Also, it's possible to change, for example, the size. If I want to put a little more higher, I do like that, and do higher, smaller. Also, it's possible to rotate the chromosome to put everything in the correct position. Sometimes it's also possible to, with this button here, set a bright chromosome. If, for example, in that case that is not a bright, I can press here and the system automatically put a bright. If I don't like it like that, I can just undo this. Okay, so in that case, the idea is to classify each chromosome in the position that is good. Here at the end, it says the classified chromosomes. There are 46, and the 46 are classified, and also the ESCN. In that case, it says 46XY. Also, it's possible here to view the chromosome prototype. I can say all, so I can see for each chromosome the prototype here. Okay. A good thing of this is that I can say if there is a problem. For example, I can mark here some areas, and after it will print in the report where is the problem. Okay. So from here, for example, if I want to just see the report, I go here in the report. Here it asks me all the information of the patient, other fields that will go directly to the database. And here you can see the report. In the report, if I have a chromosome that is selected, in next page I will see the area where I select before and the chromosomes. Okay, if I am in the metaphase and I say report, it appears the complete report with all the information and the karyotype and also the chromosome that I selected and the metaphase. Always is possible to save this work if after I want to open again and continue the analysis. Also, it's possible to import images to analyze if I don't want to analyze from the microscope. Okay, and once it's finished and everything is ready, when I close, automatically it saves in the database in the case of karyotypes. So here in the database, I can see the metaphase, I can see in the karyotype, and also I can see the chromosomes that I selected here. Okay, so if I want to do the FISH of this sample, I just go analyze again. I press analyze. And now when I select here the camera, I will go for the FISH. Now I set 3 filters. It's possible to put more filters if necessary, but I will start with the DAPI filter. And here is the image that I get from the DAPI filter. So in that case, I press and set these 3 areas. And I will now change to another filter. I use capture. And for example, I select spectrum green. And this is the image that I get from the spectrum green. When I set like that, I can always say if I want to show this in the final image or double click if I don't want to see. Now, if I set here the final image, so I see that the 2 points are not here. But if I select yes, double click, in the final image, I have these 2 points. So I can add the number of filters that I want. For example, now I want to add also the spectrum orange. These are the image from the spectrum orange. And in the final image, I can see all the points here. Always is possible to change the position. For example, imagine you have in the spectrum green, one of these things, it's very near to the other, so I can change the position if necessary to have correctly in the final image. Also, it's always possible to insert text or symbols. So for example, if here I want to write FISH, a title, I can change the font, the size. And when I press OK, I have here the title. Also, it's possible to add some symbols. For example, if I want to set a symbol like that with another size, like that, I can change and put here where I want. Okay, so it's possible to add the number of filters that I want. And once the final image is ready, I just close here and it will be saved in the database. So in this database, I have the image from the FISH and also the image from the karyotypes. Here always is possible to have the reports of the karyotype. So this is the full report of the karyotype, where I have the different pages, where I have the karyotype here, the metaphase, and the chromosomes that I selected. Also, I can do the FISH report, where in that case, it's just for the FISH image. Or I can do a complete report that I will see both the karyotype and also the FISH image. Always is possible to do customized reports. So we can design as you want with your image, with your logo, and whatever you want. Also, it's possible to capture as many karyotypes and as many FISH images as you want. And if you capture more than one, you will see here the different metaphases and karyotypes of the image. Also, it's possible here to search different samples, search by clinical history number, by the name of the different patients, the analysis date, analysts or by centers. And it will possible to check from any computer, if also it's possible to see the different analyses. Also, it's possible to connect the system with the laboratory information system to send the results, if necessary, to the system. And here you can see some reference of articles that are talking about karyotype and FISH related with infertility, male infertility. Okay. And this is all for today. So thank you very much. Now you can ask your questions in the button that you will find in the top of your screen. And I hope you like it.